Hello, everyone. This is the second in this series for the electrostatics homework. It is the problem that I have seen people miss the second most often, and I will be walking you through it for future reference. I don't know if I'm going to be allowed to share these videos before the homework is due, because I don't know if it's counted as cheating. But it is a resource that will be available to you after the homework has been due, most certainly. So let's get started. We're looking for the E field, the force of tension, the polarities of the plates. This particle is hanging in static equilibrium in between two plates. This orientation of two plates is what's called a capacitor. You'll see that further on in your circuit section. It is a very common physical system, especially in circuits. Just as a fun fact, most capacitors are actually huge because the capacitance is proportional to area. So you can actually see that a very large area increases capacitance. And so what we'll do is we'll wrap up a really thin sheet inside a really tight coil. And so a normal capacitor actually looks like this when you see it in a circuit. It does not look like two plates, even though there's a positive and a negative plate wrapped around each other as thin as tinfoil or thinner. Okay, so now let's get started on the problem, now that there's a little bit of interesting facts out of the way. We have basically a free body diagram problem. It's very similar to a Physics 1 problem. You can think of this as being sort of another tension. We have two tensions pulling on it. One is pulling over and the other one is pulling up. And since that's the case, what we can do is we can just solve for what force would give us this angle. So let's draw a free body diagram and see if that helps. So we've got the force downward, mg. We've got the force of tension, over. And we've got the force to the left, which is the force of the electric field. Now we know that the vector sum plus of these two has to be equal to the force of tension. Otherwise, this would be bouncing around or flying off or something. Now, to find this, we need to consider that these are now at right angles to each other. So we just have a Pythagorean triple. And that's this right triangle. It's the same as this right triangle here. So we know that the upward component of the force of tension is equal to Ft times, and then this is going to be the angle theta right here. I'm going to put it in there. It's going to be Ft times, and we want the upward part, so the cosine of theta. And this part is the over part, which is Ft times sine theta. Those are respectively equal to mg and the force of the electric field. Now, an important thing to keep in mind with this type of problem is that quite often we will find the tension force, or we may find these answers out of order. We may find this before we find this. For example, in this problem, it's quite easy to tell that the polarity is just sort of given. Like negatives are attracted to positives, so since this is moving to the left, this has to be, or leaning to the left, this has to be positive and this has to be negative. So for example, these answers are already sort of given in the nature of the problem. These two, we may not find them in order. So the same as the last problem that I posted, we may just work through it, and as we're working through it, we will find both by filling in all the blanks. We want to tell a whole story, and to tell the whole story, we need to find all the forces, which should give us all the blanks. Okay, so we've got that Ft cosine theta equals mg, Ft sine theta equals Fe. We've got the mass. So we know Ft times cosine theta, and we have m right here, and we know g, is equal to 0.9 times 9.8. So this is 8.1 plus 0.72. So this is 8.82. And now, because of SOHCAHTOA, we can actually just fill in cosine theta. This is opposite over adjacent. So we need to find adjacent. We have adjacent because we have two parts. So 4.25 squared minus 2 squared square root is equal to adjacent. This is 17 quarters minus 8 quarters squared. So 17 squared minus 8 squared over 16 square root, which is equal to 170 plus 72, 40, 289 minus 64, 289, 229, 225. So this is equal to 15 halves. Fourths, I apologize. So this length is 15 fourths centimeters, which is 15 fourths times, I'm going to call that length height, so the upward, which is 15 fourths times 10 to the negative 2. And now we have adjacent and hypotenuse. So we can find cosine theta. So let me clear the board off real quick, and I will get to that. And so now we've got this. We want cosine theta, which is adjacent over hypotenuse, which is 15 fourths over 17 fourths. So it's 15 seventeenths. Well, now we can find the force of tension by just reapplying this algebraically. Well, look at that. We found one of our solutions already. It was out of order. So let's write this over here and carry on. We can now find the E field because we know that sine theta is going to be the E field. So Ft sine theta is equal to Q times E. I will attach in an announcement a help sheet for finding fields. But the equation for a field is kq over r squared. And just by looking at the units, we know that this is equal to kqq over r squared over q, which is actually equal to the force divided by q. And then that means that E equals F over Q. So QE is equal to F. Now, this is not a formula you need to memorize. It is derived from this formula for the electric field and this formula for the force. It is much more useful to know that they are related by a factor of Q than it is to know exactly which one is which. You only need to know one of them. So now solving for sine theta, we have adjacent of our hypotenuse is cosine, so opposite of our hypotenuse is sine, which is 2 or 8 quarters over 17 quarters. So it's 8/17. So Ft times 8 over 17 is equal to QE. I'm changing colors to make this clear. We know these, and we know this. So Ft times 8/17 over Q is equal to E. We've just solved for E. We know Ft, which is 8.82 times 17/15. So we get that times 8/17 over Q. So we get 8.82 times 8/15 divided by, and we are given Q, -6 times 10 to the -6. So we get 8.82 8/15 times 10 to the 6th over -6. And this is the electric field. I'm not going to make any calculator errors by trying to work this out for a number. Be sure to use parentheses properly on your calculator, and it should work fine. If anybody has any other questions about this particular problem, feel free, as I said before, to email me. And then let's think about if this makes sense. So the field is negative, which means it's flowing that way, which seems proper. It means that it's pushing it that direction. So then let me write this out one more time, nice and neat, so everyone can read it, and then we'll call it a day. Okay, I'm going to add one last nice little diagram before I log off. Notice the force and the field are related by a factor of 1 over r, as are the, by a factor of q. And then along the sides, we have a relationship of a factor of 1 over r.